All right, we'll go ahead and get started here. All right, so we're going to talk about today. Long term will be pretty similar to what we talked about last chapter. A few different things, but today we'll start talking about a specific problem. We'll just label this lesson as the bouncing ball. Okay. So here it says the ball is dropped from 200 feet and bounces back up to 155 feet. All right, so the first thing we need to find is what is the rebound ratio of the ball. Okay, and so what a rebound ratio is, or the way to calculate it, would be the starting height on the bottom of a fraction. On top, we'd have the rebound height. So in this example, we would have our rebound height of 155 on top, and we divide by 200. Okay, and we'd get a decimal of 0.775. Okay, so what this really means is that the ball is going to bounce up, okay, 77%, 77.5% of whatever its drop height was. Okay, so if we kind of wanted to make a table, actually let's just call this height. Okay, setting up a table where we are looking at what bounce the ball is taking and its height on that specific bounce. So our initial height we are given, okay, before we drop it, okay, it starts at 200. Okay, second bounce ends up being 155. So what we've learned by finding the rebound ratio is that we are essentially multiplying by 0.775, okay, to get that next term. All right, and instead of adding between each term like we've done in the past, okay, we're going to keep multiplying by 0.775 to get each term. So if we wanted to find the next term, we could say 155 times 0.775, okay, gives us a bounce height of about 120.1. Just leave it at 120.1 since I'm running out of room. Okay, and then we could keep going and we can find out as many bounces as we want. 93.09. 72.15. All right, I'm just multiplying by 0.775 each time. Okay, instead of adding between each term, we are multiplying between each term. If we want to find out how high a ball is going to bounce on a specific bounce, okay, we have a formula for that. Okay, and that formula is going to be y equals your starting height times your rebound ratio raised to the x power. Okay, where x is going to be the height. Okay, x is going to be the number of bounces. So in this example, okay, our starting height was 200. We had a rebound ratio of 0.775. So our equation would be y equals 200 0.775 raised to the x. So let's say we wanted to find the sixth bounce. All we would do is plug in 6 for x. We have 200 times 0.775 raised to the x. Obviously, you would need a calculator for that. Okay, but we get 43.335 feet. Okay, notice that's what we got up here on our table as well. Okay, when we were just multiplying by 0.775 each time. Okay, obviously this would be a lot easier if you just had the equation, especially if you asked, you know, what's the 12th bounce or something like that. Having to multiply by 0.775 each time would get a little tricky. Now we just have an equation. We can just plug it in and it makes everything a lot easier. All right, so we'll do a few examples like this today. Okay, so here, balls drop from 150 feet up to 91 feet. How high does it bounce on the 8th bounce? So step 1, find our rebound ratio, which again, rebound height divided by our starting height. So we have 91 divided by 150. Okay, it gives us a rebound ratio of 0.067. Okay, your rebound ratio is always going to be in between 0 and 1. Okay, if you get something greater than 1, it's because you have these upside down. Okay, so it's important that you know it's always going to be in between 0 and 1, like so. Step 2, we're going to want to write an equation. All right, so we're using, again, y equals our starting height multiplied by our rebound ratio raised to the x. Okay, so your starting height was 150. Rebound ratio was 0.067. So we have 150 times 0.067 raised to the x. Last step would be to plug in the bounce number and solve. So the question asked us for the 8th bounce. So we have y equals 150 times 0.067 raised to the 8th. Okay, I'll show you how to do it on a phone because it's important. I'm sure some of you will be using your phones today, at least on the iPhone calculator. Okay, whenever we are plugging this into a calculator, we want to do the exponent part first. Okay, so we want to say 0.067 raised to the 8, raised that XY button right there to the 8th and hit equals. Okay, it gives us a number, and then we're going to multiply that number by 150. Our starting height. All right, so on the 8th bounce, it bounces up to 2.764 feet. Okay, if you try and do it the other way, where you said 150 times 0.607, and then you want to raise that to the 8th power, okay, you get a really big number. That obviously, does that make sense? On the 8th bounce, it bounces up to 4 trillion? 4,723,235. Nope. What comes after trillion? I don't even know. So whatever that is. Obviously, you would hopefully recognize, okay, I did something wrong, okay, and kind of reset. All right, give you one to try on your own here. All right, let's try this one. Drop from 85 feet, bounces up to 75 feet. Okay, how high is it going to bounce on the 7th bounce? If it's off by a little bit, it's just because of the rounding issues. Okay, so if you said 0.870, okay, and then if you just went straight into your calculator and found that and left it, you know, a long decimal and then plugged it in, it'd be a little more accurate. Okay, however, okay, I'm looking for an answer that's at least 32 point something. Okay, you should be on the right track. Normally we tell you, okay, round everything to 3 decimal places. So that might be a good habit to get into. All right, try the second one here. Okay, good. Seeing a lot of people doing it right again. Okay, should get something close to 16, almost 17 feet. Should get a rebound ratio of 0.75. Starting height was 300, so 300 times 0.75 raised to whatever bounce they asked for. They're asking for the 10th, so raises to the 10th power. Obviously, need a calculator to plug that in. Okay, but you should get something about 16.894.